Hi, I just peeled the tape off this end graft I glued in the other day, and it brought a few things to mind, so I thought I'd make a quick video. More about building philosophy than actual woodworking technique. As you can see, this is a tapered end graft like you would find in Martin guitars or other American manufacturers, but unlike in years gone by when this would have been made out of ivory or another plastic, I'm using solid wood like a lot of other hand builders do these days. This adds a level of complexity to the situation because you have to contend with grain direction. Guitar makers actually end up doing a lot of things that are considered bad woodworking in terms of the grain direction. We do a lot of cross-grain glue-ups and get away with it. This is one of the few places where we actually have a choice in the matter. So, most often, in classical guitar making anyway, we tend to glue in the end seam with the grain running longitudinal or at right angles to the grain of the sides. When we're dealing with a larger graft like this, what I've chosen to do is actually reverse that so that the grain is running parallel to the grain of the sides. And this comes from a couple of different instances I've seen in my repair career where end grafts like this have not shrunk at the same rate as the sides around them. What can happen is because wood does not like to shrink along its grain very much, or at least in relation to the amount that the sides will shrink, is that the sides can shrink in an area of low humidity, and it'll actually push the binding away from the sides. Or the other thing that happens is that the pressure is enough to break the bond of glue between the end graft and the end block beneath it and make it buckle. And the only way to get rid of that situation is to get in with an X-Acto knife or something and cut away some material, which makes a mess of any nicely mitered purfling scheme that's going on. So what I do is I take a piece of material that matches my binding and I orient it so that the grain runs across. And this should hopefully prevent that kind of instance. Now, we'd all like to assume that our guitars are going to be spending their entire life in perfect 45% humidity. That's just not going to happen if you've got a professional musician who's going to put them on a plane or maybe leave a bar at 1 o'clock on a January morning. So they're going to be exposed to differing temperatures and differing humidities. I like to build them so they have every possible chance of staying together. Anyway, that's it for today. Thanks for watching, and we'll see you again.